Everyone, in this video we are going to discuss about linear and angular measurements of mechanical measurement and metrology subject. So in this one, the clinometer it is used to measure the angular measurement, and clinometer and autocolimeter. So here the clinometer it is used to measure the included angle. So for that the clinometer it will be used, and also it is going to find the angle between the two adjacent sides of the component. Okay, so for that the clinometer has to be used over here. The clinometer is special application of the split level. It will be based on that. The split levels has to be maintained as a 0 degree angle. The clinometer split level is mounted on the rotary chamber carried out housing. One of phase housing forms in the base of instrument on the housing. There is a circular scale. The angle inclination of the rotary member carrying the relative its base, the measured of the circle. The clinometer mainly used to determine the included of two adjacent face of the work face. So usually with the help of this one, linear bevel protector and other measuring instrument, we can go and find the only one side angle. But with the help of the clinometer, we are going to find the two sides of two adjacent face of the angle, two adjacent angles we can find. And this is the purpose. The instrument is placed on the face of the rotary body, adjusted till 0 readings, and bubble is obtained. The angle rotation is noted on the circle scale against the index. The second reading has to be taken similar manner, and second phase of the workpiece. The included angle between the faces, then the difference between the two readings. Okay, so it will be used to checking the angular and relief angles, and also this can be used to inclinable table and jig boring and machine and angular work on grinding machine, etc. So the most commonly clinometer is of the Hilger and Watts type. Okay, so some clinometers there is no bubbles, but graduated circle is supported accurate ball bearings, and it is so designed as when is released. Okay, it is always take up the position of relative to the true vertical, the reading taken against the circle to accuracy of 1 second with the aid of vernier. Then comes into the next thing, autocollimeter. The main purpose of the autocollimeter is used to measure the small angle variations. So for that this autocollimeter has to be used, and also the small measurements. The autocollimeter is provided a very sensitive and accurate value, and also this essentially in infinital telescopic and collimeter combined into the instrument. The so the next, so the autocollimeter it is going to find with the help of this formula. O dash is equal to x is equal to 2 theta into f. So f is the focal length of the lens. Okay, so next thing we will see. So once the point on surface with the help of collimating lens, the beam has to be sends the parallel beams over here. Once the optical rays it will be sent via that the beams goes, and it hit the reflector, and again the same path it will be reflected and placed on here, means there is no difference in the component. Okay, suppose in the second drawing, if the beam rays it will be pointed over here, and it will be placed over here, and it will be reflected back like this. It is the component, it will be reflected back, and it will be placed on the o dash plane, that is the focal plane in the o dash point. So the difference between the o and o dash is the difference between the o dash is the angle of the component. Okay, so this will be calculated with the help of the reading in the mounted on the lens. Okay, so like this manner the autocollimator has to be work. The principle of autocollimator, the cross-line target reticle is positioned at the focal plane of a telescopic objectively system with the intersection of the cross lines on optical axis. At the principal focus, when the target reticle is illuminated, the reticle is used to send the, usually the reticle maybe comes over here, it will be sends the parallel beams, parallel beams, and it is used to the reticle is illuminated. Rays of light diverging from the intersection point reach the objective via the beam splitter and are projected from the objective's parallel pencils of light. In this mode, the optical system is operating as a collimator. A flat reflector is placed in front of the object and exactly normal to the optical axis reflects parallel pencils of lights back along their original paths. So they are then brought the focus of the plane, the target reticle exactor coincident with the instruction intersections. The reflector is titled through a small angle of reflected pencil of a light will be reflected by twice the angle tilt and will be brought into the focus in the plane target reticle but linearly displays the actual target cross lens by an amount of 20 degree to focal length. Okay, so in the autocollimator, linear displacement of the reticle image in the plane eyepiece, therefore directly proportional to reflector tilt and can be measured. The eyepiece reticle optical micrometer, no, um, uh, optical micrometer, no electronic detector system, scaled directly angular unit. The autocollimator is set permanently at infinity focus. The no device for focusing adjustment distance provided or desirable. It responds only to reflector tilt. So this is autocollimator. So we are watching from here the user. So the eyepiece, so the lamp is sending the beams over here. So whatever things it will be sending via, it will be goes and placed on the component, it will be reflected and comes over here. The reflector has to be placed on the word. So this is the sending image, so that it receives on the word. The difference between here to here, that we can measure with the help of the microscope autocollimator reading. The reading is to be embedded over here. With the help of that, the difference we can find over here. So like this way we are going to find the differences in the autocollimator. The angle you can find, even the small angles also you can find with the help of this autocollimator device. Okay, this is about the autocollimator. Thank you.